Have you ever realized how the hard disk of your computer system works? What is the structure of this hard disk? Okay, a lot of processes have to be served using the hard disk. You copy, you paste, you do all kind of stuff on your hard disk. How does it work? What is the most important part of the hard disk is its head. Okay, so how does the head of the hard disk works? There are some disk scheduling algorithms which decide how the head should work in the most efficient manner. So in this video, we are going to work on these algorithms and we are going to see some numericals on that. So let's get started. Okay, so we are going to see what is disk scheduling first of all. Okay, so disk scheduling is done by operating systems to schedule input-output requests arriving for the disk. Disk scheduling is also known as input-output scheduling. A lot of requests may be there on the disk to perform, like copy-paste, several kind of tasks, and several processes may have to be swept in and swept out from and to the RAM and the hard disk. So a lot of things are being done with the hard disk. So how does it schedule the various processes associated with the hard disk? How does it process each request? Okay, so that is all about the disk scheduling. Okay, so there are some disk scheduling algorithms which handle this process of disk scheduling. Okay, now you would be thinking, what is the actual need of disk scheduling algorithms? How critical is the disk scheduling? Okay, so let us see the most important points. What is the need for disk scheduling? Like multiple input-output requests may arrive by different processes and only one input-output request can be served at a time by the disk controller. Okay, many processes may be demanding the hard disk. Okay, the usage of your hard disk. That is the input-output usage from it. Like you are copying, you are pasting, you are cutting, and you are requesting some services from processes. Okay. So thus other input-output requests need to wait in the waiting queue and need to be scheduled. So there are various input-output requests coming to the disk at the same point of time. Not all can be served, only one can be served at a time. These things happen so quickly that you think that everything is going on concurrently, but it is not like that. Disk scheduling is done in such a way that only one kind of operation is performed on the disk at a time. And what about the other input-output requests? There is a special queue for that. So they are waiting in the queue. Okay, they are waiting in the waiting queue on which the scheduling is performed thereafter. So two or more requests may be far from each other, which can result in greater disk arm movement. Like one request is at one corner, the other request is at another corner. Okay, some request is at the middle. So how we can efficiently utilize the disk usage or the movement of the head of the disk? Actually, the head of the disk, which you have seen diagrammatically in the beginning, that decides the processing of the request. Okay, so the head of the disk is the most important thing to consider. So it should work in the most efficient manner. Okay, there should not be any wastage regarding that. Okay, so how can we make it work so that it processes more than one request in the most efficient manner? Okay. Third point is hard drives are one of the slowest parts of the computer system and thus needs to be accessed in an efficient manner. Yes, it is true, hard disks are slow when you access to and from regarding the data. When you access the data to and from it. Okay. In comparison to RAM, especially, it is very slow because RAM is extremely fast as compared to your hard disk. So that's why scheduling is important, so that we speed up the things. Okay. Next, one of the most important concepts regarding it is the seek time. So seek time is the time taken to locate the disk arm to a specified track where data is to be read or write. So the disk scheduling algorithm that gives minimum average seek time is better. So what is seek time? Suppose there are a lot of requests, several requests on the disk, and they have to be served each one by one. So how should the head of the disk should move? Okay, so the total time taken by the head of the disk is the actual seek time. The total time taken by the head of the disk in order to process all the requests. That is known as the seek time. Okay, so obviously if the seek time is minimum, it is better for us. Okay, so there are some scheduling algorithms which schedule the disk head to move in a specific manner so that seek time is minimized and the performance is increased. Okay, so our aim is to minimize the seek time, okay, and to minimize the obviously the head movement of the disk. So there are disk scheduling algorithms in order to achieve that. So the first one is FCFS. So FCFS is the simplest of all the disk scheduling algorithms. In FCFS, the requests are addressed in the order they arrive in the disk queue. Okay, so whatever the order is followed for the request, the same has to be processed by the disk head. First in, first out. Okay. Now suppose the order of the request is a numerical for you. Okay, example numerical. So suppose the order of request is 80, 170, 40, 140 and 20. And the current position of the read-write head is 50. So let us understand it with the help of a diagram. So let us draw a line. It is obviously not such linear line on the hard disk, but for the sake of understanding we will do like that. It is actually representing the distance. Okay, so the head of the disk is at 50. Okay, so from 50 it has to serve first of all the 80. Okay, the request is lying at 80. Okay, so it moves from 50 to 80. So these are actually the track numbers on which the requests are to be processed. So on the 80 track it goes. From there on, the next request is 170. So it goes to 170. Okay, after that it goes to 40. Okay, then after that it goes to 140 and finally it goes to 20. So what is the seek time for that? Let us see. So first of all it goes to 50 to 80. So 30 is the distance traveled. Then it goes from 80 to 170. So 90 is the distance. Then it goes from 170 to 40. So 130 is the distance. Then it goes from 40 to 140. So 100 is the distance. Then it goes from 140 to 20. So 120 is the distance. So if we add up all, we get the seek time as 470. So 470 is the seek time in FCFS scheduling algorithm. So there are some obvious disadvantages, like it does not try to optimize the seek time. So whatever the request it gets, it just goes and serve it, okay, without using any kind of further brain. Okay, so that's not very optimal solution. Okay, and it may not provide the best possible service. Obviously it is just randomly going in the direction of the request. Whatever the request comes, it goes in that direction only. Next is SSTF, which is short as seek time first. So here the requests having shortest seek time are executed first. So we know what the seek time would be for each individual request and we process that accordingly. The shortest task should be performed first. So the seek time of every request is calculated in advance in the queue. Obviously we should be knowing the seek time of every request. And then they are scheduled according to their calculated seek time. Okay. So as a result, the request near the disk arm will get executed first. Okay. So we will see the same example here. We will try to do it as we have seen in FCFS. The same example we will take here. Okay, so suppose the current position of read-write head is 50 and we draw the diagram to understand SSTF using the same case which was taken in FCFS. So the head moves from 50 to 40 and not towards 50 to 80 like in the previous case because it is nearest to it. Okay, so the seek time would be minimum in that case. Okay, so it will serve its nearest request. So it goes from 50 to 40. Okay, then what is nearest to 40? 20 is nearest to 40. So it goes to 20. Then what is nearest to 20 among the remaining? 80 is nearest to 20 and then it goes to 140 and then it goes to 170 which is nearest to it. So the requests are served based on their seek time. I mean the minimum, the seek time, the or more priority will be given for its execution. Okay. So what is the seek time? It is quite simple. We are going from 50 to 40, so 10. Then we are going from 40 to 20, so 20. Then we are going from 20 to 80, so 60. Then we are going from 80 to 140, so 60. Then we are going from 140 to 170, so it is 30. So the total seek time is just 180. So you can see the difference, how much difference we have got. Like in FCFS, you have seen the seek time as 470. So you would be amazed to see this, that how much the seek time has been reduced because of the scheduling algorithms. So the main advantage is overall seek time decreases. What is the disadvantage? Overhead to calculate seek time in advance, because the system should compute the seek times of all the processes in advance. Okay, only then you would be able to use obviously SSTF. The next is scan algorithm. So in scan algorithm, the disk arm moves into a particular direction and services the request coming in its path, and after reaching the end of the disk, it reverses its direction and again services the request receiving in its path. So it's simple, like the path is from here to here. So in scan, the head of the disk works like this. It goes to the end, then it goes to other end, and whatever the request comes in between, it just serves it. Okay. So basically it just scans through the entire path, and that's why the name of the algorithm is scan. Okay. So we will consider the same example as seen in FCFS. We would see the same example as seen in FCFS. So we'll draw the diagram here. And here also the current position of the read-write head is 50, just like in the previous two cases. So now we will see how scan algorithm works. Okay. So it goes from 50 to 40. Suppose the head starts to move in the left direction. So once it starts to move in the left direction, it will go to the leftmost, and then it will travel to the rightmost. Okay. It will scan through the path. So it goes from 50 to 40, then it goes from 40 to 20, and then it goes to the extreme left, even though there was no request to be served, but it still goes to the extreme left. This is all about the scan algorithm. Then from 0 to 80 to serve it towards the right, and then from 80 to 140, and then from 140 to 170, and from 170 to the extreme right, which is 200. Okay. So what would be the seek time? It would be 50 plus 170. It's quite simple. 50 because it goes to the leftmost. Okay. And plus 170 because the last request comes at 170. Why not we have added 50 plus 200, even though it goes to the 200 distance at the right? Think about it. Look, the definition of seek time, let us revise. The seek time is the time to serve all the requests. So the last request towards the right was served at 170. So at that very moment, our seek time is finished. So we will calculate the seek time till the time head moves to the last request and not to the end of the disk. So towards the right, the last distance is 170 to be served. Okay. So we will not add up 200, we will rather add up 170 to 50. Okay, so the seek time will be 220. So the main disadvantage is the requests at the mid-range are serviced more, and those arriving behind the disk arm will have to wait. Like if it starts moving left, it will serve all the requests towards the left. So it starts serving left, it serves all the requests towards the left, and the rightmost requests will have to wait. They have no other option. Okay. Then we have the next algorithm, which is C-scan. So in C-scan algorithm, the disk arm, instead of reversing its direction, goes to the other end of the disk and starts servicing the request from there. So the disk arm moves in a circular fashion, and this algorithm is also similar to scan algorithm, and hence it is known as C-scan. Okay. So what happens in the C-scan? We will see the same example here, and the current position of the read-write head, as in the previous cases, is at 50 only. So now we would see what happens in case of C-scan. Okay. So the head of the disk is at 50 track. Okay, so now it will just go to the extreme left. Okay, while going towards the extreme left, it would serve the request coming in between like 20 and 40. Then it will just go to extreme right without serving the request. That is the main difference between scan and cscan, that in cscan it goes back to the path without serving the request. It just straight away changes the end, and then from here on it will start servicing the request in the left direction only. Okay, so now it would serve all the requests which came in its path. So the seek time would be 50 towards the left, then 200 without servicing any request, plus 200 minus what is the last request which was unserved initially. So towards the right of 50 there is 80, which would be the last request to be served. Okay, so it would be 50 plus 200 plus 200 minus 80, that is 370. Because the seek time counts the time taken to serve all the requests and not regarding the extreme right, the extreme direction. Because the arrow, this head disk moves to the extreme direction, but we will count only till the time the last request is served by the head in the seek time. Okay, so I hope you are able to understand all these algorithms. These are very important for the examination point of view. So in case you like the video, then please do hit the like button and please do subscribe the channel in order to get more such useful content for yourself. Okay, in order to get a written PDF material for your quick revision, do join our Telegram channel, link for which is given right there below. So do join us, and please do join our Facebook group where we periodically update you. We will post job updates and many more useful educational updates for you. Okay, so it would be very useful for you if you could join the Telegram and the Facebook group. Okay, and I hope you are enjoying yourself and I hope you are having a good time. So please do comment in case of any doubt, and I wish you happy learning.